Okay, given that y equals x cubed plus 3x plus 4, find dy dx from first principles. So what I'm going to do is choose 2 points on the curve. Okay, a general point P, okay, which would be my general x value. Okay, x can be anything. And of course then, to work out y, well, it's just based on the curve there. So y would be whatever x cubed plus 3x plus 4 is. Now what I'm going to do then, point Q, is the distance h across here, yeah, along the x-axis. So Q, the x value, will be x plus h. And then, if that's my x value, to work out what my y value is, just sub it in here, okay? So it'll be x plus h cubed plus 3x plus h plus 4. That's what my q value will be, okay? My y value there for q. So what I'm going to do then is, I'm going to look at the gradient of the chord p to q. Okay, so the gradient of chord p to q, and remember that will simply be, because it's a straight line, y2 minus y1 over x2 minus x1, okay, using the coordinate geometry formulas we learned. So this of course is going to be my x2 y2, and this will be my x1 y1. So I'll do y2, which is all of this, all of that there, take away my y1, which is this here. Now, because I'm taking it away, don't forget to put it in a bracket, just show I'm taking away all of y1. On the bottom then, x2 is x plus h, take away then x1, which is x, and then as always happens, the x's cancel, you're just left with h, okay? So what I'm going to need to do here then is, I'm going to need to expand, okay, the x plus h all cubed. Alright, so you're better off using binomial expansion. Okay, so there's my Pascal's triangle there. So remember, a plus b all cubed will equal to a cubed. Okay, the next coefficient then is 3, and it'll be a squared, then b plus then 3ab squared plus b. Better off using that. So then, in a sense then, you'll replace the a with x and the b with h. Okay, so if we sub it in, we get x cubed plus 3x squared h plus 3x h squared plus then h cubed. I missed that out there. Okay, expand that bracket then, I got 3x plus 3h. When you expand this bracket, plus then the 4, and then the minus then applies to everything here. So minus x cubed minus 3x minus 4. Okay, so the x cubes cancel, the 4's cancel, the 3x's cancel. So I'm just left then with these terms at the top. So 3x squared h plus 3x h squared plus h cubed plus 3h all over h. And what I want you to notice then is that h is a common factor, yeah, on the top. So you can extract that common factor. Okay, and then they will cancel out, so we end up having 3x squared plus 3xh plus h squared plus 3. Now, remember now that's the gradient of the chord PQ. What I want you to appreciate then is as we let h get smaller and smaller, Q will get closer and closer to P, and it will end up, as you h get really, really small, it will end up homing in on that tangent and become the tangent. So what we say is, the tangent gradient then, which is dy dx, will equal to the limit as h goes to 0 of all of that. And of course then you can see as h is 0, they are 0, so you end up with 3x squared plus 3. And a simple check then to the question, you realise then that actually, yeah, it should be 3x squared plus 3 when you differentiate it the normal way.